Hello, everybody. I'm now done reading all your quadrat samplings report. And first of all, I want to tell you that the general picture is that you have really improved your report writing skills. I can see that you are using the comments that you've gotten earlier on, and many of you are writing very nice reports. So that's really good. Good job. And then in this screencast, I'm going to give you some general feedback on the report, and then there's a little task at the end. But first, some general comments. So first of all, I want you, or those of you, there's a few of you that continue to use sort of the report skeleton that you got in pre-IB. And it's not that the skeleton is bad, it's just that the skeleton is sort of designed to help you learn how to write reports, and then eventually you should sort of skip the skeleton and then do it yourself, right? So of course keep the headings and all that, but if you continue to put it in a table like this, it doesn't really look that independent. And when you write the IA, which is basically what we're practicing for when writing all these reports, then it's very important that it looks like your own work, right? And placing the whole thing in a table like this makes it look sort of as if you're just following a recipe. So skip the skeleton. And then this is what a layout could look like without the table, right? So this is a nice layout, right? You can see the headings are still the same, introduction and list of materials and all this, but it just looks more independent. And then I asked for just a short introduction, so it's perfectly fine that many of your introductions are not very long, but some of them are too short, I would say. But I think that almost all of you are explaining the quadrat sampling method and introducing sort of the chi-squared test. And that's of course good and very relevant to do in your introduction. But for the next report, the line transect report, I want you to include more background information, more relevant background information. So I've just taken an example from one of the reports that one of you have handed in this time. So what could be an example of relevant background information? Well, a little bit of information about the different species, for instance, right? So this student here has looked up some of the traits that sort of define these two species that the person is working with. And that's very relevant because this is theory that you can then draw on when discussing your results later on in your report. So for the line transect report, it will be important to include information about the local climate, right? Some of you are in different countries, and some are in the countryside, some are maybe more in a city, some will use a garden lawn for this. So information about where in the world and what the climate is, and also the weather on that day will be important to know as well. Something about the area. Is it a mountain area? Is it a hillside? Is it close to a little stream? Is it a forest? And if it's a forest, then what type of forest? So also something about sort of the vegetation type. So a little bit about this, and perhaps also something about the abiotic variable or the abiotic factor that you will be investigating. So do you expect it to be more dry in one end of your transect and more humid in the other end, or something like that? And how might that abiotic factor then affect the plants growing along your transect? Yes, and then if we move on to the data analysis and the quadrat sampling report, then I have made a mistake in the video when calculating the area, and some of you have actually corrected that in your reports. That's very nice, and some of you have not, and that's perfectly fine because it's my mistake. So you've gotten a tick mark even though 225 square centimeters is 0.0225 meters squared, and not, as I got, 0.225 meters squared. I have corrected the calculation in the video as well, but I just wanted you to know this. But like I said, it's tick marked in your report, but it might still be a good idea to fix it so that you don't make the same mistake again. And then I really want to sort of try once more to say something about the chi-squared test, because I could see that many of you are still struggling a little bit, sort of understanding what it is that's going on and how to interpret the chi-squared value and the p-value. So I've taken an example from one of your reports, this student has looked at these two species, the bellis and clovers, and have gotten these numbers when collecting data outside, right? So in 12 quadrants, both were present. In 9 quadrants, none of them were present. And then only bellis, and then only the clover. And this is what we observe out in the real world. When we go outside and we look at what it actually looks like, this is what we get, right? So these are the observed data. Then what you do when you calculate your expected values is to say, what would it look like if there were no association between these two species? If they didn't try to avoid each other, if they didn't seem to grow in the same area, if it was just random, if there were no association between the two species, what numbers would we then expect, right? So that's actually what you're calculating. So based on the assumption that there is no association between the two species, then we would expect both of them to be present in 11.2 of the quadrants, and bellis to not be present, but clover present in 15.8 of the different quadrants, and so forth, right? So these are the expected values based on the theory that there is no association between the two species. Yeah, so what is it that we're then doing with the chi-square test? Well, the chi-square test is testing if there is a significant difference between what we observe when we go outside and collect our data and what we would expect to see if there were no association. So the test is testing whether there is a significant difference between observed and expected numbers. And our null hypothesis is that there is no significant difference between the observed and the expected numbers or frequencies. So what does that really mean then? Well, since the expected numbers are what we expect to see if there is no association between the two species, what that means is that if there is no difference between what we observe and the expected numbers, then there is no association between the two species. We also have the alternative hypothesis that there is a significant difference between the observed and the expected frequencies. And if that is the case, if there is a difference between observed and expected frequencies, that means that there is an association between the two species, because the expected values are based on the theory that there is no association, and if those numbers are very different from what we see, that means that there is an association between the two species. I've also tried to sort of produce a little diagram to show some of this. So the example we just looked at, in that example, the student found the p-value to be larger than 0.05. This means that the null hypothesis is accepted because the observed numbers are then not different or not very different from the expected numbers, which means that there is no association between the two species. So if the p-value is larger than 0.05, the null hypothesis is accepted. There is no significant difference between observed and expected numbers, and the two species are not associated. And if we then again take a look at the numbers that I showed you before, we can see that it makes sense, right? Because these are the observed values 12, 5, 15, 9, and they're not that different from 11.2, 5.8, 15.8 and 8.2, right? So the observed numbers are pretty close to the expected numbers. So it makes sense that there is no significant difference between observed and expected numbers. And since these are the numbers that we would expect if there were no association, and since these numbers are very close to that, our conclusion is that the two species are not associated. So if, on the other hand, we get a p-value that is smaller than 0.05, then we reject the null hypothesis. That means that the observed numbers are different from the expected numbers, which means that there is an association between the two species. And this is another example from one of your reports. And again, we can look here. These are the observed values 10, 8, 16, 40. And in this case, p-value smaller than 0.05, null hypothesis rejected, significant difference between the observed and expected numbers, and the two species must then be associated, because these numbers are what we expect to see if there is no association, and since these numbers up here are pretty different, that must mean that there is an association. And again, if we compare, you can see it's 10 up here and only 3 down here, and it's 40 here but only 18 down here, right? So it makes sense that there is a difference between observed and expected frequencies. Yes, so hopefully that explanation will help you sort of improve a little bit about the writing sort of that you have done, or the explanations that you have written for your chi-squared test. So have a close look at that text that you have written to make sure that you actually get it right. Then I also want to remind you that I think it's a good idea as part of your discussion to have a table like this to get sort of an overview of the potential sources of error. And you should of course only include those that are relevant, right? So, but it shows good understanding to actually be able to sort of list and also take into account what the expected effect on the data is, and also come up with possible suggestions for improvements. So this table should be part of your discussion. First, I would recommend that you start your discussion off by sort of summing up your findings, and take a closer look at that and say, well, it makes sense because so and so and so, and yeah, so a little bit of writing before, and then this table, and then a sum up at the end of your discussion. Yes, so based on what I have now told you, and based on the comments that you have also gotten in your own report, I want you to choose 3 things that you want to improve in your quadrat sampling report. And you should of course then improve them. And then I want you to take screenshots, and for each screenshot, I want you to write a short explanation of what it is that you have improved. And then you upload this to the table in OneNote. And here are just some suggestions of what you could decide to improve. So it could like be the whole layout of the report. If it's in the table form, in the skeleton from pre-IB, then I suggest that you remove that. You could also maybe correct some of your calculations, write a bit more explanation, correct the explanations of your chi-squared test. You could add a bit more background information. You could insert the sources of error in a table. You could make sure that your methodology is written in past tense. But choose whatever makes sense to you. And it can also be just teeny tiny things. So as long as you learn from it, that's the important thing. Yeah, that's it for now. Bye.